Live from San Jose, California, it's theCUBE, covering innovating to fuel the next decade of big data. Brought to you by Western Digital.
Hey, welcome back everybody. Jeff Frick here with theCUBE. We're at the Western Digital World Headquarters. It's the Almaden campus in San Jose. If you know anything about the tech world, you know there's a lot of innovation that's been happening on this campus for years and years and years. Big announcement today called Innovating to Fuel the Next Generation of Big Data. A lot of exciting announcements, and here to join us to tell us all about it is Brendan Collins. He's the Vice President of Product Marketing Devices for Western Digital. Brendan, great to see you.
Thank you, glad to be here.
Absolutely, so really exciting announcement. You know, I've talked to Kim Stevenson at Intel. We had an interview talking about Moore's Law. Right. And one thing she really reinforced is that Moore's Law is really more of an attitude than it is specifically physics. And whether you want to argue the physics is one thing, but the attitude for innovation to continue to deliver a lot more for less just continues. Right. And you guys announced a huge step in that direction today.
Yeah, we have a challenge that storage is growing at a rate of about 40% per year, and budgets in the data center are not growing, right? So the challenge for us is to develop new technologies that allow us to stay on the technology curve and cut costs and do that efficiently.
And this is a big one, so let's jump in. So actually it was years ago, I was actually at the event when you guys introduced the helium drives, and that was a big deal there, and you've continued to kind of move that innovation, but then you could see a plateau in the density of this data, so you guys had to come up with something new.
Yeah, what we've seen is that our PMR technology that we use currently is slowly running out of steam, right? So in order to come down the cost curve, we needed to boost areal density. And luckily, we were able to come up with a new breakthrough in MAMR technology that will allow us to do that for the next decade.
Well, it's interesting in the talk, you talked about you guys could see this kind of coming, and you actually put a lot of bets on the table. You didn't just bet on MAMR, you bet on HAMR, and you continued along a number of multiple tracks, and you've been at this for a while.
Right.
What was kind of the innovation that finally gave you a breakthrough moment that got us to where we are today?
Well, there were multiple technologies that we could have invested in, and we decided to continue on the two major ones, which were HAMR and MAMR, but we made a decision to invest in a process called, a head fabrication process called Damascene, that allowed us to extend the life of PMR for the last 5 to 6 years. And it's been in all the products we've been shipping since 2013.
And you talked about the areal density. So that's basically the amount of information we can put on a square inch of surface area. Exactly. And you've attacked it on two vectors.
That's
One is how many tracks, so just think of a record, right? How many tracks can you get on the album in terms of the number of lines, and then how much density then you can have on each of those tracks. And you're announcing major improvements on both of those factors.
Well, if you look at, we've had 3 enabling technologies in our products for the past 3 to 4 years, right? One is helium, one is micro actuation, and the other is the Damascene process. Damascene and micro actuation actually push track density, which enables higher capacity. But the newer technology that we're talking about, MAMR, addresses both vectors. So we push the track density even tighter together, but we also boost the linear density at the same time. And we do that without adding cost.
Right. And the other thing you talked about, and I think it's a really important piece, right, is not only the technology breakthrough, but it's also how does that fit within the existing ecosystem of your customers. And obviously, big giant data centers and big giant cloud providers. We actually have a show going on at a big cloud show right now. And this technology was innovative in that you got a breakthrough on density, but not so crazy that you introduced a whole bunch of new factors into the ecosystem that would then have to be incorporated into all these systems. Because you guys not only make your own systems, but you make the media that feeds a whole host of ecosystem partners. And that was a pretty important piece.
If you look at some previous technologies we've introduced, whether it be even 4K sectors in the industry, or shingle magnetic recording, both of those require host side modifications, right? Anytime you have host side modifications, it generally slows down the adoption, right? With HAMR, one of the challenges that we had was because of the concerns with thermals on the media, we needed a process called wear leveling, and that required whole software changes. In contrast, when we go to MAMR, everything is seamless, everything is transparent, and it's great.
Right. I thought it was much simpler than that, though. I thought just heat is bad, HAMR's heat, and MAMR's microwaves, and you know, heat and efficiency in data centers, and all those, you know, kind of again system level concerns. Yeah. Heat's never a good thing in electronics.
Well, and in the case of MAMR versus HAMR, there's like an order of magnitude difference, right, in the temperature on the disk, which is the key concern.
Right. And then, of course, as you mentioned in the keynote, this is real. You've got sample units going out. Correct me if I'm wrong. As early as next year.
That's right.
And hoping to be in scale production in 2020, where some of these other competing technologies, there's really still no forecasted ship date on the horizon.
Yeah, you can generate samples, you can build lower quantities of these HAMR drives, but you still have that big concern out there in front of you. How do I address the reliability? How do I address the complexity of all these new materials? And then if I got all of that to work, how do I do it commercially because of the cost adders?
Right. So I just want to get your perspective before we let you go. You're busy, high demand for your time. As you kind of think back and look at these increasing demands for storage, this increasing commands for compute. And I think one of the data points given is, you know, the data required for humans and machines and IoT is growing way faster than you know, business-focused data, which has been the driver of a lot of this stuff. And you just kind of sit back and take a look, you know, what are some of your thoughts? Because I'm sure not that long ago, you could have never imagined that there would be the demand for the types of capacities that we're talking about now, and we both know that when we sit down 5 years from now, 10 years ago, you know, 10 years from now, we're going to look back at today and think, you know,
Absolutely.
That was zero.
Yeah, way back in the day, there were just PCs and servers, and there was traditional IT with RAID. Today, with autonomous cars and IoT and AI and machine learning, it's just going to continue. So that exponential growth that you saw, there's no sign of that slowing down, which is good news for us.
Yeah, good job security for you for sure.
There you go.
All right, Brendan, well again, thanks for taking a few minutes to sit down and congratulations on the great event and the launch of these new products.
Thank you, glad to be here.
All right, he's Brendan Collins, I'm Jeff Frick. You're watching theCUBE from the Western Digital Headquarters in San Jose, California. Thanks for watching.